Well, let me begin then. The first panel was excellent. And now welcome to panel 2, maximizing use of the International Space Station. The co-moderators are Oleg Kotov and Petitt. Leroy already gave introductions in the previous panel, but let me add a few comments. Oleg, as you know, is a veteran at Cosmonaut, who's now Deputy Director for Science at IBMP in Moscow. He trained as a physician, achieved the rank of Lieutenant Colonel in the Russian military, and was selected as a cosmonaut in 1996. He's logged more than 526 days in space, having flown 3 long-duration ISS missions, Expedition 15, 2223, and 3738. He's also performed 6 EVAs. Don's a chemical engineer and veteran astronaut of 2 long-duration ISS missions, Expedition 6 and Expedition 3031. He was also a mission specialist on STS-126, and his cumulative time in space is more than 369 days. He's an avid inventor, innovator, and educator, not only in space, but also in other extreme environments such as Antarctica. I think this is going to be a great panel, and I hand things over to our distinguished co-moderators and panelists.
Hello, everyone, and again, good to see all of you. By the way, the questions are done online now. Have you seen them?
I don't see him, but I think you can just go ahead, and he'll join.
Okay, I hope so, because we a little bit split our responsibility to represent our panelists. Yeah, let's.
Just sent a chat. He entered the audience link, so he'll be joining very shortly.
Okay, good. Again, so again, first of all, again, it's a very common topic what we have today for our discussion. Every year we are trying to discuss how we make efficiency of the ISS more, how to improve our science program and technology program, but every year we're facing how our space program changed very significantly, and especially relatively to exploration mission. And I'm glad we have many few speakers in our panels who is very widely involved in the process how to use the ISS as a test bed or facility analog for moon exploration for next project. And so it's really very important because we are working not only fundamental or classic science, which of course is very important, but we're mostly trying to solve all our roadmap for critical technologies, what we need to fly toward to their moon and beyond. So in this case, I'm really glad to introduce our speakers, and I prefer to start with Bonnie. Bonnie, okay, over to you. And Bonnie, as a speaker, will represented in the previous session as my colleague and astronaut with huge experience, and now professor and chief of laboratory. It's ridiculous to pronounce A&M University, and excuse me, I little missed in all your titles what you have, but again, I'm glad to hear what you are with us today. You're here, and please, over to you, Bonnie, please.
Okay, Oleg, thank you very much. I didn't have the opportunity to fly in the station, but I had the opportunity to train in Russia and dock twice to the Mir space station. And our shuttle flights as part of phase 1 or shuttle Mir helped to lay the foundation over those 3 years or so for the partnership that we have now on the International Space Station. And I'm so glad also to see Liz Warren with us through CASIS, because I think our vision of the station, going back to 1993, when I was at NASA headquarters, and we won the congressional vote by 1 vote to build the station, that vision has been implemented from the first flight Bill Shepard was on to over 20 years of providing a platform for research, not just fundamental research that applies to our understanding of biological and physical and medical processes here on the Earth, but also lays the foundation for exploration, understanding the effects on the human body, developing advanced life support systems, looking at spacecraft design, radiation protection, applications in Earth observation. It's really been an amazing platform. Having that platform there and always having a LEO platform is going to be foundational for future exploration. What I'm doing here and what many of us are doing in the university environment is creating the workforce of the future. That workforce has lived their whole lives in 1G. A partial G environment is not intuitive. And so it is a discipline. It's a design discipline. It's a scientific discipline. And so in the lab that I have in advanced spacesuits and fluid physics, trying to introduce this variable so that it's just part of the vocabulary for this next generation. Systems engineering, human system integration, advanced spacesuits, fluid physics, that's what we're focused on here. Thank you.
Yeah, thank you, Fanny Bunny. And Don, I see you already online.
I am online. I had the misfortune of logging into the wrong link, but now I'm here in the panel. And thanks, Oleg, for carrying on while it took me to the time it took me to get here.
Okay, so I know so computer systems is always something strange. I know. And please, Don, over to you. Please lead this session.
Okay. One thing you get to do if you're leading a session is you get to kind of set the mode of the session, and I want to keep the introductions small, so that we can leave time to have a maximum interaction with the audience and the questions. Because for me, these panel discussions are all about getting questions coming in from students and other folks that are tied in and letting the panelists think about them and respond. So with that, let me go to my list here. So Bonnie's already talked. Elena, Fomina, why don't you give a brief introduction? Elena is at IBMP in the Russian Academy of Sciences, and she has been working in the field for many, many years. So Elena, go ahead and say a few words.
First of all, I would like to thank all organizers and especially for George Abbey for this opportunity to see everybody of you. And I hope that next year we will meet face to face and it will be exciting. And now one of the options of this summit to us speak in Russian, and I will use this opportunity in order to tell more than by my English. Thank you very much, and I will speak on Russian now.
I think that using the ISS as a platform for further exploration to the moon and to Mars is one of the most important opportunities, because out of all the analogous system we have, it's only the ISS that gives us an opportunity to imitate the conditions of future flights and the combination of them and see what will be done during the interplanetary flights. When we simulate flights during the dry inversion or other ones, we have only we can only partially simulate the conditions. But when we have the ISS as a living model and which is maximum close to the conditions of the moon or Mars, we should take advantage of that while we have the International Space Station. And first of all, I wanted to say that during the year that we didn't have an opportunity to see each other in person, we are continuing and pressing on with the lunar programs, especially now when we have experiments on board the ISS, such as Prophylactica countermeasure experiment. So what we are testing during the experiment is different methods which will be useful for lunar flights as well as Martian flights. It is evident that for the lunar modules that Oleg already was talking about earlier, we will not be able to provide as many countermeasure resources as we do for the ISS currently. Therefore, right now we are evaluating which means, which countermeasure tool that we have is working, and we have another annual flight that Peter Dubrov is implementing. So we are trying to evaluate the compensator of the loads. So when we look at the standing position at the feet, and when we look how the missing loads for the feet will be compensated using that particular simulator. Of course, we cannot simulate everything, and we cannot compensate instead of the treadmill, but it can be an add-on tool to the arsenal of our tools, countermeasure tools for our cosmonauts and astronauts. Can we outfit the Eagle module that we talked about or not?
So for a long duration expedition, we are thinking about a 5-day interval when a crew member is going to be using only the velogometer. And of course, his ability to work is going to decrease, but it's not going to be as dramatic as we could expect. There is another interesting case that we managed to put in place during this expedition. We tried to use a treadmill for 2 days, and you know that the Russian countermeasures considers the treadmill the ultimate tool to prevent loss in your workability. So we allowed Piotr to not exercise on the treadmill. His ability to work has decreased because the tests that he took prior to that period of time and after, at the time when you are recovering after exercises, there was a change to his heart rate. So I would say that for long duration missions, we can actually use a different cadence, different schedule of exercises. And of course, we have to increase the number of one-year missions that are going to be to make it more realistic and help us prepare for long duration missions. And you understand how precious the information, the data that we gather are. And I would like to call upon all our agencies to work together, because everything that we know about physiological changes in cosmonauts and astronauts is precious experience, is precious knowledge. And it is important to do it all together, because every human being who is in zero-G environment during a prolonged period, we need to study the biochemical changes in their bodies. And it's a shame that sometimes we do not have the opportunity to exchange data only because we do not have a unified system to measure the changes that could be applied, would be applied by all parties. We are also starting an isolation experiment that started on the 4th of November. And we're using volunteers to participate in VO2 max experiment. So we decided to use something that our partners use so that we were on the same page. And that would allow us to develop countermeasures. We are very careful with our protocols for ARED. And thank God, there are very few cases when we observe SANS syndrome in our crew members. So I think that this is partly due to the fact that we are not recommending high loads on the ARED workout machine. So it's really interesting to see what results we can achieve if we use Russian or US, our NASA protocols for countermeasures. So this is all I wanted to say. It is very important for us to save every single piece of information that we gather. Thank you so much.
Thank you for those words. Now, let's move on to Bill McArthur, who we all know as Billy Mack, and he is a NASA astronaut. He's flown a bunch of times on the shuttle, and he's also flown on Soyuz, done a long-duration mission to station. So Billy Mack, give us a few words.
Okay, Don, I'll sure do that. And thank you for that very kind introduction. It's good to see you. So, you know, we're discussing many of the similar things that we've discussed before, and of course our topic here is how do we get the best value from ISS? What's maximizing? How do we maximize use of ISS? And you know, we know that the research on board ISS is important because that's really going to be the key to further and further exploration. And, you know, we've discussed during past ISMS conferences the importance of sharing facilities and data. What I'd like to take and so the challenges presented to cooperation within the ISS partnership have generally been addressed agency to agency. And fortunately, we have the structure of the ISS program to provide the organization to address these issues. And of course, part of it is protection of intellectual property, which is valuable to each of the nations that are part of the ISS partnership. But there's now a new variable, and those are the commercial users. Are they going to introduce similar impediments to efficient use of the ISS? Of course, the value of intellectual property to commercial users of ISS, whether it be technological innovation or research data, may be an impediment. And we really need to recognize, while we like to think that as representatives of government space agencies, we're driven by altruistic motives, we of course need to recognize that if we're truly going to commercialize space, there needs to be some return on that investment, which I think will exacerbate this desire to protect intellectual property. But of course, if data isn't broadly shared, there'll be duplication of effort and loss of data integration with the resultant impact to efficiency and, unfortunately, wasting resources. So I think that is a challenge that that ISS partnership is going to have to address. But even more broadly, if we look at potentially autonomous research being done in space, how do we capture that data? How do we integrate that data into the body of knowledge that we are gaining from ISS? Again, if we want to maximize the effectiveness of ISS, I would suggest it means we're going to have to embrace these autonomous, independent researchers on orbit. We need to embrace them and bring them into the broader community. I'm going to change paces I'm going to change direction just a little bit and ask, how valuable is the data from ISS? I think we all believe it's extremely valuable. Well, what's happened during the pandemic? We've all been challenged. But I think, unfortunately, one of the things NASA needs to address is that, they have lost several years, 2 to 3 years of longitudinal data looking at spaceflight experience and the long-term medical impacts. And so I would challenge not just NASA, but the ISS partnership to address trying to capture the data that they have just not been looking at for the last 3 years. And again, Don, thank you for the kind introduction, and it's a privilege to join the group today.
It's always good to see my colleagues, and in particular, what kind of background you have. And I love that view, Billy Mack. Let's move on. And I'm just going down the list of panelists that I received here a couple of days ago. And let's go to Julie Robertson. She is currently, I believe, on assignment at NASA headquarters, because I haven't seen you around Johnson Space Center in a while, Julie. So please fill in where you currently are, because I've lost track of that. So Julie, give us a few words.
Well, thanks, Don. And it's good to see you here if I don't see you at Johnson Space Center. So I am currently working at NASA headquarters, setting the integrated strategy for research in human spaceflight, which means a strategy that includes both ISS and Artemis missions, with a focus on preparation for Mars. So to address the topic for this particular session, as we look at ISS in its third decade, there are 2 key pillars to that long-term utilization and maximizing the use of ISS. One is its continued use as a platform with ever increasing commercial participation, but as a platform for research in microgravity and for product development and other commercial purposes in a microgravity environment. The second pillar is the use of ISS to prepare for exploration. And in the first 2 decades of ISS, we really focused on use of ISS as a microgravity analog for the transit to Mars, that transit phase to Mars. Oleg and I have been working very closely together with a group of international colleagues over the last 18 months in a number of virtual forums to define how we can address on ISS the other 4 hazards of human spaceflight: the isolation and confinement, the distance from Earth, the hostile closed environment, especially. And how can we do research on the ISS that is getting us toward integrated solutions that will help us build the right hardware for Mars missions? And we call that endeavor, we've kind of renamed it as we worked with our international colleagues, taken on a name that was out in the international community called ISS for Mars. And Oleg and I have worked closely together to help define a set of boundaries around that make sense in terms of safe and effective operations of the ISS, but also help us start understanding some of the key questions that we haven't been addressing well so far. Things like gravity transitions, and especially of deconditioned crew members that have been in orbit for a long period of time. Also, how the crew will work together autonomously when they can't communicate immediately with mission control all the time, which is a really significant change in the way that we do our operations. And we're using the ISS to help develop both not only countermeasures like Elena talked about, but also the integrated crew health and performance system, test all those components on the ISS, then deploy them in cislunar orbit in the transit habitat in Artemis, test that for a few years, and then turn around and take that habitat with a crew to Mars. So the intent is to accelerate the readiness for Mars human missions by connecting effective use of the ISS with the effective use of Artemis and other spaceflight platforms, as well as ground analogs. Thanks so much.
Thank you for those words, Julie. Really important details to keep track of. Now, moving on to our next panelist, let's hear a few words from Liz Warren. And she used to be at NASA and a part of some of my missions, but now she is at CASIS, and she is the manager for the ISS National Laboratory. So Liz, give us a few words.
Absolutely. Thank you, Don and Oleg. And thank you, of course, to Mr. Abbey for providing a forum for these conversations. As Julie said, the role of the ISS National Laboratory and what we hope to evolve as to a low Earth orbit national laboratory among other commercial platforms is really, to provide space station access to the research community seeking to leverage various aspects of the ISS or low Earth orbit environment to benefit life on Earth, and of course, further commercial goals, as Billy Mack mentioned. So, diverging a little bit from what Julie was talking about in terms of exploration goals, I'm going to talk a little bit about another use of space station, which is to bring tangible benefit back to Earth. Of course, there's a lot of overlap in just about every research investigation that you may perform on ISS. There are both Earth benefits and space exploration benefits. I want to focus on one of our topic areas at the ISS National Lab, which may be somewhat new to some of you, and some of you may have heard me talk about this last year. It is relevant to this audience. And I want to talk about disease modeling in space. We are seeing millions of dollars of investment from our National Institutes of Health, our National Science Foundation, NASA, of course, but also commercial and academic partners, and even some benevolent donors are now getting involved in this research. So in addition to rodent research models, which were brought up a little bit earlier, recent advances in bioengineering, coupled with the amazing and an increased capacity to perform extremely complex R&D investigations on the space station. These have led to some very compelling developments in stem cell biology, organoids, bioprinting, and microphysiological systems, or tissue chips. And I've got one right here in my hand. This is a tissue chip. So essentially, three-dimensional, multicellular, either organoids or tissue chips can recapitulate or mimic human physiology more accurately than standard two-dimensional cell culture models, and are even more relevant than a lot of animal model studies because they use human cells. And as you are all very familiar, spaceflight induces a number of physiological changes in our crew members. What's relevant here is a lot of those changes appear similar to several maladies here on Earth. Immune dysfunction, bone loss, sarcopenia, muscle loss, and disuse issues. So this makes studying astronaut health in space very interesting to researchers who are interested in disease processes, onset of disease, etc. Because one, these changes in spaceflight happen very quickly, and two, well, I'll say three things. Two, because they're largely reversible upon return to Earth, and three, these are happening in otherwise exceptionally healthy people. So these unique features altogether could provide some novel data for pharmaceutical companies, researchers that are interested in these topics for the development of therapeutics to treat patients on Earth. So it really gives us some very insightful windows into what is happening in diseases and disease processes. Now, tissue chips also, and they may be coming up later in another panel, they have interesting implications for precision medicine for astronauts. So imagine a flight surgeon like Dr. Paterini being able to send some of his crew members' cells to space, maybe surface of the moon, far before the crew member ever launches, to get some critical insights into maybe how this individual is going to adapt or acclimate to the spaceflight environment. We may be able to customize countermeasures for each crew member. So we could put Don Petitt on a chip or Shep on a chip, send the chip to the moon, and get an idea of how 1/6 gravity is going to affect this individual. So there's quite a lot of work that needs to still be done in this area. It's very encouraging to see significant government investment in this research. HRP is involved, ISS National Lab is involved, Trish is involved. All of this toward commercialization efforts as well. I'll close with saying we recently published a summary of a biomanufacturing in low Earth orbit symposium. If you're interested in reading more, I can send people a link if they want to get in touch with me. It's a preprint, so it's available to everyone. And I think I'll stop there. Thank you.
Liz, those were amazing words, and I think it would be a really bad day if Shep and I were on chips, available on chips. But if you go that direction, I think you need to put George on a chip as well. With that, let me move to Luca. Luca Parmitano is a panelist. He is an ESA Aussie astronaut, and he has flown to space station now 2 times. And let's see what Luca has to say. So Luca, give us some words.
Hey, hello everybody. It's great to see so many friendly faces. Thank you for inviting me, having me. I always feel a little bit not quite comfortable in such amazing company, especially talking about something that to me is more about policy and programs. And at my level, I consider myself 100% just an operator. But I can tell you what, from the operator point of view, somebody that just came back from the International Space Station, what could help the astronauts on orbit maximize their time and their capability, especially from what I've seen. And the first point, I would think that we still need to let people know what we do. We just don't do enough. It is heartbreaking when I often go to conferences and talk to panels, even at prestigious universities all over Europe, that they really are not that aware or really informed about the science that we perform on the International Space Station. Not only they don't know what we do, but even if they wanted to to have access, they wouldn't know how. So I believe that the first step will be spreading still, even more than we do. We need to do it more. I imagine that there might be a backlog of societies and universities and groups of people that want to perform science and are still waiting for their chance. However, we may be missing excellent opportunities for very valuable science simply because there are a lot. There is just too many. There's just too many people that don't know what the space station does, how we do it, and how to gain access. The second step, and I think Liz probably is not hearing it for the first time. The second step is to provide access to these to scientists and personnel that want to perform science on the space station. I still think that it needs to be simplified. There needs to be a strong simplification of the procedure to gain access to the procedures and to the space station itself for science that would be valuable to be performed on the space station. Now, at the same time, while I was in orbit, I was surprised to see that some of the science that we were performing some of the experiments, let's call it that we were performing at the time. In my very humble opinion, as a technician and as an operator, was not up to the standard that I was expecting. And I'm not talking about the science performed for outreach reasons. That is obviously is of a different kind, especially if we're talking about young students performing science, sending their experiment. I'm talking about experiments that were sold to us as a technological innovation, and to be honest, I was not really happy with what I was doing, how I was performing, and the reasons behind it. So I hope that the quality of the science and the technology that astronauts are asked to perform in orbit improves, because that would be maximizing the time that we spend in orbit and the incredible efforts and amount of money spent by the different countries and the different programs. So 2 points that are programmatic, basically, make it more available in terms of knowledge and make it more available in terms of access. The third point, I actually agree wholeheartedly with the idea of having a part of the program improving our capability to live on the space station in a semi-isolated way, as we would do on a trip to Mars or an extended time. We are still heavily relying on communication and capabilities from the ground in order to perform our activities in orbit. And I think if we want to improve, we need to do things that might sound a little bit uncomfortable. And we can initially do it in a very safe environment like the International Space Station. Later on, we'll have the chance to improve on that by building and operating on the gateway, which I hope to see flying, and which I hope to be part of. Hopefully not on a microchip, but with also the rest of my limbs and body parts. But in the meantime, we could certainly imagine making the ISS a very high level, high fidelity environment to learn how to operate independently from the ground control.
Luca, thanks for those words. I love your background. It looks like it's a black hole that's going to swallow you up. Please do not go below the Schwarzschild limit or you'll disappear forever. with that, let me move to our last panelist, and it's Bill Shepard. He's already been introduced. So Shep, take us on home from the panelists talking, and then we'll open it up for questions. And by the way, if you have questions, please start typing them in. If we don't get any questions, then we'll just be talking as panelists. So please type in questions if you have them. So Shep, take it away.
Okay, Don, my bandwidth looks to be a little bit limited. So if I drop off, press on without me. But I want to commend Elena and Luca for hitting the aspect of using ISS as a Mars surrogate. I think it's exactly the right thing to do. I would like to emphasize that some of the things that I think us Americans have learned, particularly from our Russian partners, is the value of getting together for years before we fly and establishing good cooperation as a team. It's not something that we used to do all that directedly by our training in Houston as shuttle astronauts. But I think the psychological compatibility of the crew and people who can understand leadership, responsibility, and accountability in flight is hugely important, particularly on isolated missions. The other thing is that we're going to have to basically fly people who understand autonomy and the ability to be self-sufficient. And the last thing I'd like to say for utilization is I would like to see the partners in the program step up to looking at advanced power and propulsion. We talked long and hard early on for doing a solar thermal energy generation system. It was canceled due to funding. I'd like to see that come back in the near term with a big solar reflector and probably some sort of closed heat cycle like a Brayton cycle. If we're going to do advanced high power systems on the moon and on Mars, we're going to need this technology now. And that's what we should be looking at. Over to you, Don.
Good words, Shep. And I'm a big proponent of organic Rankine cycle if you're operating in space using solar power. Let's see what we have for questions. Whoops. That was probably a typo. So let me see. Here's another question. And by the way, I'm really pleased. We have about 30 minutes for question and answers and discussions with folks. So I'm really pleased that we have reserved that amount of time. So let me read this question, and this is to Dr. Liz Warren. And it says, I am a second-year MD, PhD student interested in tissue modeling for technologies and their use in human physiology. And talks about the technology, the chip technology is really cool stuff. And getting down to the question, do these mass requirements for the chip technology, can it be used as a screening tool? I'd love to read some papers on the biofabrication on the ISS. Thank you.
Hey there, MD, PhD student. Glad that you're tied in today. We definitely need you to come work for us in the space program and bring your new knowledge and up-to-date technologies. So I see two questions. One, first of all, the chips are extremely complex. They're hard to use here on Earth. So using them in space is a big challenge. What it has caused and driven us to do is a lot of miniaturization and automation. Some of the different payload developers or engineers that take what scientists do on the bench and make it something that can be done on ISS by a minimally or not at all trained individual has driven the technology to use very automated systems that are hands-off entirely, or some of them are fairly complex and involve a lot of crew time. So it's we're seeing two different technology developments. These are very complex, and yes, you need to bring, you have to have an incubator, you have to have a freezer, you have to have tubing, and you have to have fluids that are moving, and you can't have air bubbles. So all of the challenges that you might be able to think of and more are involved. Now, in terms of using these as a screening tool, that's a pretty touchy subject, and it might get talked a little bit about in one of our future panels. At this point, astronaut screening is something that is separate from what I'm involved in. And understanding the genomics of astronauts, that's a very other topic. You can ask maybe Dr. Paterini if he's still around, or Dr. Mike Barrett, or Mary Van Balen in one of our future panels. So right now we're not doing that. But again, maybe one of the most interesting aspects is once an astronaut is already selected, so not part of screening, once an astronaut is already selected, it may be interested to, send an astronaut with their own cells at the same time in space, or like I mentioned earlier, send the chip first, before Luca goes to the moon, send his chip to the moon, or even one of our, our unflown astronauts. There's some interesting questions there, but again, maybe even a more interesting question is to send these chips with patients on Earth that already have a disease, send the chip to space, or a healthy individual, test some therapeutics, because we know that these chips are going to behave just like humans in space for the most part. So that paper on biofabrication, if I'm able to type an answer, I'll send you the link. And that's all. Thanks, Don.
Liz, I would like a copy of that paper link too, because the idea of these biochips, I find is a game-changing thing for mammal cell tissue cultures. Do any of the other panelists have any comments on this last question dealing with chips? Okay, I'm waiting for more questions, and currently that is it. Just to fill up dead time, I'm going to make a comment here about what I've been thinking on maximizing the use of space.
Okay, it looks like we lost connection. It looks like okay, Don, you are with us again.
Oh, okay, can you hear me? 1, 2, 3. I'm going to turn my video off. Okay, testing 1, 2, 3. Can you guys hear me? Testing.
We hear you.
Well, you hear me? Good. I turned my video off because I think there are bandwidth problems. Let me just go back to what I was talking about, an extension of space station. I think to maximize the use of space station, we don't want to shove it in the ocean in 2028. And if you look at other pieces of complex technology that were not meant to go on and on and on, for example, the T-38s that we use for astronaut training, and they're still used by the Air Force and the Navy for pilot training. These things were designed in the mid-50s, built in the 70s, and we've overhauled them multiple times with cockpit upgrades and engines, and replaced major structural components like longerons. Look at the B-52, look at the KC-135. If we want to extend the life of a complex piece of technology, we can seem to figure out how to do that. And even though these technologies were never meant to last as long as they're currently put in service. So I think if we could keep space station going by appropriate political support and funding, there could be no end in how long we could keep that thing in orbit. So with that, let me see if there's any more questions. And I'm seeing some questions come in. Okay, let's see. Here's a question for Luca. As someone active on two sides of the ISS coin, and I'm thinking they're meaning both ESA and flight, do you have thoughts on how to best promote the capabilities of the ISS for science to persons who may want to use the ISS but not know how? So Luca, over to you.
Well, I'm not sure exactly which side of the two coins I am on, but again, I especially because, like I said, I consider myself an operator, so really one side. The only other aspect that I can think of is myself as a communicator, and obviously, well, not obviously, but what I was referring to was that I think we need to actively engage in the conversation. And what I mean by that is usually they send me to talk to universities when the universities ask ESA to have an astronaut for a conference. And then I go, I show up. Most people have no idea what the ISS space, what the program is, what the ISS is, what we do, and how it works. And then after I talk to them, myself or a colleague or any of us, then they are surprised about the capabilities that we have, what we can do, and how we can do it. So I think that the paradigm needs to change in the sense that we need to be actively going for talks. We need to ask universities, hey, I'm going to send an astronaut to talk to your students about what we do. And because you are the university, the Politecnico of Milan, because you are the Institut Supérieur de l'Aéronautique de l'Espace in France, because you are the MIT, and because you are the Caltech. So I'm going to send you at your next conference, at your next big meeting, at your next whatever you do, I'm going to send an astronaut to talk to you, and take it or leave it. And because I don't want to wait for the university to call ESA and say, hey, can we have an astronaut? We would like to hear about this mission. I want to be able to launch the bomb and let them think, hey, this is what we do, and we want your ideas, we want your brains, we want your enthusiasm, we want your great futuristic, unthinkable ideas that we don't have anymore. So I think that the answer, in short, is reverse the paradigm. Instead of waiting for them to call us, let's be us going and talk before they call us.
Luca, I think you brought up a good point about how we at NASA deal with scientific conferences for astronauts. Typically, we can't go unless the conference pays for our way to go as an astronaut. Yet scientists from NASA have their own funding, and they can go to multiple conferences a year. So that's one problem is we are not allowed to go to conferences unless we are invited and someone pays for us. And then when we do go to the conferences, we usually fly in the morning of, give the talk, and then oftentimes we're flying out that evening. They don't let us stay at the conference and actually participate in the conference. And my recollection for when I actually was a scientist and able to go to conferences, so much of the benefit came from hallway talk with your colleagues, drinking coffee, discussing things on doodles of paper. And that's so much of the value of the conferences. And we as NASA astronauts do not get to attend a conference. We can go to a conference, but we don't attend to it. And I'm wondering whether any other panelists have anything else to say on how we can disseminate what's going on to space station into the scientific crowds.
Don't let me say a couple of words about just to fill the pause about new option we got recently. We are facing again as like a PAM, as a private astronaut mission, or flying the professional flyers with or calling it civilian flyers who are not a professional astronaut or cosmonaut, who, for example, had only a short limited training for space flight and going to do such flights just once and perform specific research aboard the station. And I think it's new age and era. And I know we had in our history this kind of researchers we call as cosmonaut researcher and or payload specialist during the shuttle age, but again, it's a little different because it took time to be trained to do that, because those guys has from reduced but full training to fly to space. But now we really have opportunity to launch the people after 3.5 months of training, just generic training, and launch them if in case we need some scientists in space. So there's a question for panelists. What do you think about that? I mean, let's start with Julie. What do you think about that? Thank you.
I'm sorry, Oleg, I didn't hear the full question.
Okay, so I'm just talking about opportunity to launch scientists to space after the short training. For example, narrow science is very specific for specific experiments.
Yeah, that is one of the kind of exciting areas that is being explored by commercial spaceflight, and especially providers that are interested in doing commercial low Earth orbit activities, because a number of the professionals from other disciplines that have been buying some of these early flights do have science backgrounds to some extent, or technical backgrounds. A lot of them, of course, have Silicon Valley technology type backgrounds. And I think that over time, the low Earth orbit sphere may become a little more like Antarctica and a little less like just government spaceflight. So, for example, when humans began exploring Antarctica, there were government expeditions that were sent, and most of the people were part of those kind of government-sponsored activities. But now, the way that we are exploring and doing research in Antarctica is with National Science Foundation support and a variety of commercial providers that provide the infrastructure to help the scientists do their research. So it is possible that that kind of transformation could take place in low Earth orbit over time as we move from the space station era on to that commercial low Earth orbit kind of model. But at the same time, we who are pushing the exploration boundary to the next destinations, whether those are missions to the moon or missions onto Mars, we will continue to need low Earth orbit as a testing environment, whether it's an environment to help an astronaut be sure that they're ready and well-trained and ready to operate in space and get experience in gravity transitions before they go on a future mission without evacuation, for example. So I think we will always have both systems and crew testing that needs to be done in low Earth orbit as we continue to refine and improve our crew health and performance systems.
Yeah, Julie, thank you. And does anybody has another words, any thoughts about that? Okay, and Don, it looks like we have another question. Please, over to you.
Yes, we do have another question, and this one is for Julie, and it has to do with, are we planning to do any experimenting on station with communication delays for other space missions like going to Mars? So do we have any plans for that in the works there?
Yeah, so we are having discussions about how we would do that. We have the capability to do both space to ground and ground to space comm delays on the space station today. Getting that built into the software when we were doing an upgrade was the easy part. The much harder part is to take a set of systems and operational approaches that were designed for ready communication on multiple channels and do the software and the procedures and all the approaches to operating in a comm delayed mode. So right now we have some teams that are working on plans. We also had an early test of autonomy in doing medical care. So we did a set of tests with the ultrasound where rather than being guided by the ground, which is the way that we've done ultrasonography testing of the crew in the past, instead, we actually redeveloped the software in such a way that it would give the crew members all the feedback they needed. And they demonstrated their ability both to do routine measurements, routine ultrasounds, as well as to independently diagnose a simulated medical event. And so those kinds of simulations, sometimes they don't take very long, but they really teach us substantially about how we can do better in designing the systems that will have to support the crew on that really long trip to Mars.
Julie, your answer with the ultrasound shows that crew members, astronauts are trainable. Thank you for that.
Not only that, if you give them the right tools, they can make good decisions for themselves. And that's something that we're not used to doing. That's really a powerful transformation in the way that we operate in space. And the ISS is the best place to test that.
And having a little chute that a banana flavored pellet comes down every so often could also help. With that, there's a question for Liz, and it has to do with going to science meetings again, having the freedom to go to science meetings, between what you found at CASIS versus when you were at NASA, and also throw in there in terms of your experience with the crew office, because you know that we kind of march to the tune of a different funding drummer in terms of our travel. So Liz, say a few words about the value of conferences and what it means to be a scientist at NASA versus a scientist at CASIS versus what you've observed with astronauts.
Okay, thanks, Don. And yeah, I see your question there, Sue. Astronauts, NASA astronauts, I assume, ESA, JAXA, and cosmonauts as well have some unique limitations on what they can do. I used to work in Julie's office, and Julie really pioneered the art of science communication and informing the broader scientific community about the benefits of performing research in microgravity, largely because a lot of people have never even considered what would happen to their science topic if you removed that ever-present variable. Everything they've ever done has had 1G influencing their science, and very few people actually even think of the ability to remove that or to use gravity as a variable. So actually, Julie, when she was the chief scientist of the space station, pioneered, I think, the most incredible efforts to communicate that ability. even so, boy, it is hard. So to answer the rest of the question, Sue, as far as I know, both CASIS and NASA personnel, scientists, maybe not astronauts, are free to attend a number of science conferences, and we do. And we are out there providing information, and actually our PIs are out there at individual research conferences, Materials Research Society. Yes, ASGSR is preaching to the choir, but you mentioned FASEB, experimental biology, Society for Neuroscience. Absolutely, we are out there. Our PIs are out there. It's still sometimes a little bit hard to be heard over the, just a little bit of noise compared to the rest of the messaging going on. But we're out there talking about results. We're out there talking about the benefits of doing research in low Earth orbit. We're out there, CASIS in particular, is out there speaking to a lot of commercial industry, like Bill McArthur mentioned earlier. We've had participation from pretty non-traditional companies like Delta Faucet, performed a research on shower head technology in space. You wouldn't necessarily think of that as a traditional use of microgravity, but they were looking to improve their products. Or Procter & Gamble, makers of so many different colloid solutions in your cabinet. They've actually got some patents based on research on colloids to improve shelf life and improve product quality for things like fabric softener and detergents. But anyways, Sue, to answer your question, we're out there. You're out there, I know, doing the same. It is tough. It is tough to get the word out there, and we need as many people as we can. Bonnie, I know you're out there educating the next generation of researchers, but we need more of it because, as Julie said, we need to have a continuous laboratory or laboratories in low Earth orbit. NASA is just going to be one of those customers using those laboratories, and as more and more access is provided, we hope there's more and more customers.
Thanks, Liz. I see that Shep has his hand up. So Shep, tell us something here.
Yeah, I just want to double down on what Julie said about astronauts and maybe giving them a little more license or rope to do things. On our flight, we had at least 3 pieces of hardware that when we tried to fire them up, they were broken. And the ground did not have an immediate fix to the solution. And they promised to provide repair for the lost capabilities that was going to arrive months after we departed the space station. And in the cases that I remember, we successfully fixed those 3 things that were broken and then got royally chewed out by the ground for doing it. And this is the kind of stuff this is the relationship between the ground and the crew that we have to fix, because that type of thing is going to happen a lot on a Mars expedition.
Shep, I'm glad I'm not the only one that's been chewed out by the ground for fixing something.
Yeah, we offered to break it again, and the ground said, no, let's just leave it running.
Yeah, interesting. Well, I think this is, I do not see any more questions coming in. If there's a last minute question, quickly type it. And we've got like 2 minutes left. If any of the other panelists have any more comments to say, please say them now. Otherwise, we'll give folks a chance to have a coffee break. So anything either from the audience as a question or anything from from other panelists.
So just to add something to what Shep said, that type of relationship sort of translates into the crew. I mean, because look who crew members are. I mean, you're talking about people who take initiative and do things, and so you learn pretty quickly that it's easier to ask forgiveness and get permission. And so it sort of encourages the crew to fix things instead of going through. I mean, we had a problem with a foot restraint on STS-92, and we knew what the problem was, and the ground said, well, hey, we'll send you up a procedure in the next day or two. And so our response was, well, is the procedure going to involve taking these 6 screws out, removing this extra plate, and putting the screws back in? And they said, yes, that's what it's going to be. And so, and our answer was, well, don't send a procedure because we already did that. So that's the kind of thing it encourages. And Shep's absolutely right. That won't work going to Mars. I mean, the crew is going to have a lot of autonomy and training to fix things that are broken.
Good words, Billy Mack. Anything else before we close? It's right on time, just like Leroy was able to stop the lunar session on time. Here's one quick question.
I would like add only one point. When we speak about Martian mission, we have to do a special selection of our crew, and they have to be maybe more creative, mostly creatively. If we will have opportunity to have a choose, we have to take creative cosmonaut or astronauts, because from my experience, when we have our experiment on board or some problems with our means, treadmill or something else, we see that our cosmonaut can do by themselves sometimes even more than they will waiting for our suggestion for solve these problems, because they have all view, and when we are on the ground, on the earth, we have the opportunity to analyze situation as good as them when they are on station. That's why I think that for our psychologists, it is one of the point for selection of crew, that they have to be very creative, and then don't waiting for the some suggestion from the earth, because sometimes they have even better decisions than we when we are on the console. This is very short my addition.
Thank you, Elena. Let me end with one comment from Dan Burbank, and he wrote in a comment that said that the way that it is essential to have public communication, public outreach, both scientific and to the general public, so that the people who are paying for these programs through their taxes understand what they are getting. So that's paraphrasing a comment that was made. And with that, let us end this panel. We are 3 minutes over, but that's okay. And we can start in on the next one, which is a different link. So thanks for tuning in. Same place, different station.
Okay, thank everyone. And second, but big pleasure to have panel with you. Take care. Bye-bye.
Thank all the panelists. Great panel.
Bye-bye. Thank you very much. I am really happy to see you, everybody.